Okay, chapter 5.2, this is video 3, so the conclusion of 5.2. Again, we're verifying, so we can pick either side. You could go this side, left or right. I'm going to pick right, mainly because of this fraction here and having that 1 plus sine A. I'm going to multiply this right side by the conjugate of that, top and bottom, just because I don't want to try to make this equation, simplify it, try to make it worth a 1 over sine A there. I mean, it's possible, but the better way is to come over here. And we're going to go 1 minus sine A, 1 minus sine A, okay? The conjugate over each other, that's times 1. So 1 minus sine A over cosine A. Cosine A. I am not going to distribute this in because I have a feeling something's going to cancel out. Down below here, I'm going to have 1 minus sine squared A. At this point, we should have seen enough of these that I should not have to explain why when I multiply 1 plus sine A times 1 minus sine A, I get 1 minus sine squared A. Okay, by now we should have that into our toolbox and understanding that. In fact, we should have had that back in Algebra 2, but even within this class, we've done enough of these that we should have that set. So 1 minus sine A over cosine A. Cosine A over 1 minus sine A. And then the Pythagorean identity tells me that 1 minus sine squared A is equal to cosine squared A. Okay. Again, you should know your Pythagorean identity and know it enough to know that. All right. Then I'm going to take this cosine A and I'm going to cross those out, cancel those out, cosine A, that cosine A. Oh, that leaves me with 1 minus sine A over cosine A equal to 1 minus sine A over cosine A. So really not too many steps on that one. It's just multiplying by the conjugate and go from there. All right, next one. Guess we're going to distribute out the tangent x. Anytime we have two values within, or at least two values within the two terms, that's kind of our hint to factor. Secant squared x minus 1. Secant squared x minus 1. Again, from the Pythagorean identity, we should recognize that to be tangent squared x. Tangent x times tangent squared x equals tangent cubed x. So tangent cubed x equals tangent cubed x, check. Pretty straightforward. These two are a little bit crazier. And again, with this problem, you could either pick either side to simplify to make it look like the other. Neither one is more, they're both kind of complex. In this case, since one is tangent, one's cotangent, we should probably think about rewriting whichever one we pick in terms of the other one. So what I'm going to do is I'm going to pick the right side. So I'm going to keep the left side the same. Sorry, sloppy writing. Okay, so I'm going to write this. Cotangent we know is 1 over tangent. So that'd be 1 over tangent x plus 1 over tangent y, reciprocal property. Okay, and then up here I'm going to have well, this would be 1 over tangent x tangent y. Since this is the product, those are multiplied, cotangent x times cotangent y. So we're doing 1 over tangent x times 1 over cotangent x would be 1 over tangent x tangent y minus 1. Okay. Okay. I want to get rid of this fraction. So I'm going to multiply this by tangent x tangent y, top and bottom. By doing that, if I multiply here this times this, okay, those will cancel out. That'll leave me with, well, let's do the top, well, let's do the bottom first. That'll leave me with 1 minus, and then I'm multiplying here, tangent x, tangent y. And on the top, when I multiply this to here, the tangent x cancel out, leaves me with tangent y plus, multiply here, the tangent y's cancel out, so it leaves me with tangent x. Might as well go ahead and make this in red too. Oh, and that's it. Oh, there. Wow. That was all I had to do. Boy, that was not nearly as complicated as I made it seem in class. All right. I'm going to just leave that sitting there for a minute. I'm going to just draw a red line, blue line here for this problem. So this is cosine cubed x sine to the 4th power x equals sine to the 4th power x minus sine to the 6th power x times cosine x. Okay. Why don't we well, I guess why don't we well, I guess let's see. Let's factor out. Can we do that? Could we factor out a sine 4th power x? That would leave me 1 minus sine squared x, wouldn't it? Yeah. Okay. Oh, this is pretty straightforward. Sine to the 4th power x. 1 minus sine squared x is going to be cosine squared x cosine x. Okay, so that was the key here, is just to factor out the sine 4x. It leaves me 1 minus sine squared x, which equals cosine squared x. So this equals sine to the 4th x. And multiply these two together, and that gives me cosine cubed x. And then we just have to rearrange. Since we're multiplying, it doesn't matter which goes first. So let's just keep this one the same. And then rearrange this so it's cosine cubed x sine to the 4th x. Okay. I don't know why I'm boxing that. Check. Okay. That actually, those were looked very difficult. It didn't take much though. just kind of have to think of how can we rewrite things. So the key here was looking at this, identifying the fact that we could factor out the sine 4x and leaving us with this 1 minus sine squared x. Then we can use Pythagorean. So we just have to look at how we can pull things out, distribute, change, so that we create a value, a term that we can use, like the Pythagorean identity, to change it to a different trig function, and then that way it kind of all falls into place. And that's it for this page, right? Yep, that's it for 4 point or 5.